Here we are at example 3C from our 4344 notes. We're asked to factor the following. Now, in just looking at this, we do notice that we have a trinomial. We typically try to factor out that greatest common factor. It's usually our step one, that, again, greatest common factor. Unfortunately, though, there's nothing that they all three have in common here. This first one and this last one are divisible by 2, but the middle guy, unfortunately, is not. And so none of them are divisible by 7. That's a prime number, so that's kind of hard to try to factor stuff out with. And as a result, unfortunately, we can't do step 1. Step 2, though, because we are talking again about a trinomial, we typically then try to go down to those two different binomials. So breaking this up into two different parentheses. Right, next, just looking at the number 6, just this first coefficient, 6, we notice that that is not a prime number, that actually has many different combinations to be able to give you 6. And so we're going to go ahead and create a small list of those different values. So for example, 1 and 6, when you multiply the 2, you get 6. Likewise with 2 times 3 would also give us 6. Now, typically, again, we've mentioned this a little bit already, but we try to stick to numbers that are kind of closer together as opposed to ones that are a little bit further apart. So right now, we don't necessarily know if 2 and 3 are going to work, but we're going to try it out. And then, as always, the x times the x gets us the x squared. Now looking at our last number, 2, kind of lucking out when we make that list, we end up with just comma 1, comma 2. Now this is where we can kind of identify that maybe placement might matter, because here we have a 2, here we have a 3, kind of impacting our values when we distribute. So let's go ahead and just try putting a 2 here and a 1 here. Let's just see what happens. Well, if we distribute, we end up with our 6x squared like we normally end up with. Kind of already knew that was going to happen. And then when we distribute the 2 and the 1, we end up with 2x. But then when we distribute the 2 with the 3x, we get 6x. And then lastly, the 2 times the 1, we get our positive 2 that we're hoping for. When we try and combine these two middle numbers, unfortunately, we just don't end up with that 7 in any way. It doesn't matter if one's positive or one's negative. The best we can get is pretty much 8. And that's not 7 that we need. So as a result, it's possible that maybe the x's need to get switched, or we generally try just the numbers without the variables first. Okay. So let's go ahead and maybe just swap the 2 and the 1. So let's go ahead and put the 1 here and our 2 right here. Now again, the 2x times the 3x, we still get 6x squared, and likewise when we multiply the 1 times the 2, we still get the last number 2. The real issue is kind of what's going on in the middle here. But now that we've gone ahead and swapped our numbers, we should see some different values happening in the middle. So 2x times 2 gives us 4x. And then 1 times 3x gives us 3x. Well, those can definitely be combined in a certain way to give us, in this case, negative 7x. Well, in order to get negative 7x, we know that this guy has to be negative and this one has to be negative. Because then negative 4x minus 3x, that gives us the grand total of negative 4x, or 7x, I'm sorry. Now to get this negative 4x here, we know that this has to be negative, and to get this negative 3x here, this has to be negative. Because again, negative 1 times positive 3x, that's how you get them. Likewise here. Negative 2 times positive 2x, you get this guy. And as a result, we kind of had to play with the numbers, swap some things, but this is our most factored form. Again, that is example 3C from our 4.3, 4.4 notes.